Hello, good afternoon, good evening, good morning, wherever you are. Welcome to this new episode of Small Talk. I'm Enrico from Avance Coperta, and we have here Barry O'Reilly. Welcome, Barry.
Hello.
Hello. How is it going?
It is good. It's good.
Fantastic.
It's cold, but it's good.
Cold but good. Cold in Sweden, right?
Yeah. We're having our first snow.
Oh, wow. Well, then it's cold.
Yeah.
Okay, so thanks, Barry, for joining us for this new episode of Small Talk. This is our series of interviews with trainers where we try to understand a bit more in very simple terms about our new workshops. And not sure you've seen it, but we have Barry coming to Milan next year in April for his Advanced Software Architecture Workshop, which is another name for Residuality Theory, which is what's behind it, which is the main topic of what we are going to talk about today with Barry. For any questions, actually, please do send us questions on the chat. The chat is open. We are live on YouTube and LinkedIn. So hello, everyone who's following us. We are going to read the questions as we go along. Hey, Giovanni, ciao. We were actually just talking about Turin with Barry, because turns out he's been there a few times. So hello. So off we go, Barry. So what are we talking about? It's your workshop is going to be a 3-day workshop in person, and it's about residuality theory. Would you like to introduce us to your workshop and what is it about?
Yeah. So the workshop is called the Advanced Software Architecture Workshop, and it's really a workshop for people who are looking for more advanced techniques and new techniques for doing software architecture, and it has its roots go back over 10 years now, where I started trying to answer the question of how do we teach architects to be architects? What is it that they actually do? And what is it that we need to teach them? And what's the difference between a developer and an architect? And what actually is architecture? And this was a project that I took on in 2013 while I was working in the role of the global lead for the solutions architecture community at Microsoft. And obviously at that time, we were undergoing a massive change where we were moving from these huge on-premise platforms, things like SharePoint and CRM and BizTalk, into the world of Azure and cloud. And suddenly developers and architects were working outside of the boundaries that had been drawn for them for a very, very, very long time. And they had to suddenly piece together solutions from many, many different, PaaS cloud components, and had to start thinking architecturally on a different level, and needed a much better grasp of distributed systems and decision making and following things up and testing and verifying their architectures. And I started to think about, well, what is it that we should teach them? What does an architect need to know in this modern environment? And I started digging into, obviously, the materials that were already there and already available to software architects. And obviously, in the course of the last 25 years, a lot of the traditional architectural tools that we've leaned on, like requirements engineering and process mapping and capability mapping and all of these heavy frameworks that we inherited from the 80s and 90s, had started to be questioned. And so part of that work was saying, well, do these things actually work? Are they actually necessary? Do we need to? Is the architect some kind of oracle who sits in the middle of a project and makes all these decisions? Or is there a lot more going on? And what the conclusions I came to were that we're using entirely the wrong tools and entirely the wrong underlying philosophies to describe architecture. And I started to dig into the complexity sciences, looking for ideas and inspirations about how do other professions, how do other disciplines deal with working with problems when we don't actually know what's going on, when we don't have models that we can easily refer to, when the ground keeps shifting beneath us. And it turns out there's a fair body of work there that's very relevant to software engineering, but it hasn't really been touched seriously, and it's certainly not in an academic sense. And I started putting these ideas together, and I came up with something that originally was called antifragile systems design, which was a way of building systems that would survive in environments where we don't know what's going to happen. Because in truth, that's what an architect does. You have to design a system and you're going to put it into an environment and you don't know what's going to happen in that environment. And but when you put it into that environment, it will live or die based on the structural decisions you make about the software system. And so that's essentially what we do. We make decisions about the structure of a system, and we don't know what that structure is going to be exposed to. And over time, I started talking about these ideas. I talked about it at DDD Europe way back pre-COVID, and started to get a lot of interest in what I was doing. And I decided to take a very different path than a lot of other sort of thought leaders in the IT industry. And I said, I'm going to do this properly. I'm going to go back to university. I'm going to turn this into a research project, and I'm going to scientifically beat up my own ideas. And I'm going to either prove or disprove that this actually holds in reality. And right now, we're getting very close to the point of publishing and saying that actually we've shown that this holds in reality. And the product of that has been something which can be called residuality theory, which is a set of ideas that combine ideas from philosophy, from the complexity sciences, and software engineering to produce a very lightweight set of tools that help us to navigate uncertainty and to turn uncertain situations into coherent software architectures without any hand waving or hocus pocus or magical thinking, in a way that's validated and verified and can work. And the result is a completely different way of thinking about software architecture, a completely different way of relating software to the environment that it has to exist in and to the world that it's inevitably connected to.
Super. Okay, so we are really into something completely new by the way you describe it, which is totally exciting and good to witness. One thing that already got my attention even when we were discussing about the workshop was the actual scientific, I wouldn't say background, but maybe validation is the right word, that you wanted to give to the whole thing. Not that other things don't have it, but I realized straight away that you really wanted to stress this out. Why was that?
What I found was when I was teaching architects, and generally if you're a junior architect on a theoretical basis, there's very, very little for you to grasp onto. There's a bunch of books that get recommended. There's stuff on patterns that get recommended. But the honest truth about architecture is that most of us learn how to do jumping in head first and dealing with it. And you either sink or swim as an architect. You pick it up or you don't. And no one really knows how that happens. No one really knows what it is that works. And what tends to happen then is when you meet architects and you meet senior software engineers out there in reality, those who aren't yet senior, who haven't really arrived yet at a sense of confidence in their architectural ability, they are going through this whirlwind of ideas and books and blog posts and memes that they've picked up, and they tend to find themselves believing in things a lot of the time. And so when I'm teaching architects, one of the first things I have to do is get them to question their current set of beliefs. So where has this come from? Why do you believe that this particular process or framework or methodology actually works in reality? What's the evidence that this is real? And even if you've got it to work in a bunch of projects, That's not scientific evidence. That's just, that could be coincidence. You don't know that it's the actual method or the framework or the thing that you do or the book that you've read or the language that you use that's given the result. There's no way to separate these things. And so the first part of training architects when they're junior is to push back and say, these ideas, this catalog or this toolbox that you bring with you, how do you know that that's what's actually working? And a big part of it is getting architects to understand that it's not the toolbox that's delivered successful projects and delivered successful architectures. It's you. It's your ability to think through problems. And all of these tools and frameworks, they're mostly just ceremony and other people's opinions that you've borrowed. And I found that when I started to take this perspective, I would listen to people talk about, you have to do this and you have to do that and you have to stand up in your meetings and you have to do this and all of these things. And every time I would ask the question to myself, not openly, where's the scientific verification for what's being said here? Where's the proof that this actually holds? And there never is any. And that led me to being deeply skeptical about a lot of the work that's out there and a lot of the recommendations that are made. And so what I wanted to do was to separate my work from that kind of thinking and say, actually, look, there is proof that this, or actually I've disproven, because that would have been an interesting journey. I've disproven that these ideas don't work. So at least we know now there's one thing that doesn't work. And that would have been a step forward for us. And also it's given me a chance to really deeply think about what for me initially weren't scientifically arrived at ideas. These were heuristics. These were things that I picked up during my own career, habits that I formed. And so being able to put those through this validation and verification from, very grumpy academic people who won't let you use a word without defining it and things like that, that makes something much, much richer and much more solid at the end of the day. And so that was my motivation for doing it in this particular way. I want to be able to point at something and say, this holds, this is real, and build something concrete that won't be washed away by the next trend or wave or hyped up thing that comes along. And hopefully also make architects, when they're exposed to this thinking and these kind of ideas, a little bit more rigorous in their approach and a little bit more skeptical to people who are trying to sell them things as well.
Super interesting. So on one hand, I see like the need to, how to say what doesn't work. It's a starting point rather than, we've been doing this for X years kind of discourse. On the other hand, I think, so you are putting together a set of principles and tools that are working also in very new things and things you don't know. How is that exactly working? So how do you have a scientific basis on something that's new and uncertain and we don't know about it yet?
Yeah, so the way to do that is to design an experiment. And so, and if you go back to the YouTube videos from for example, DDD Europe, where I show the way that this approach works, is that we take an architecture, any architecture, we say we have this problem, how would we solve it? And you come up with a very quick sketch and you say, this is my naive architecture. And the way that this approach works is, rather than gathering requirements, rather than seeking information from people directly, rather than asking the question, how should this work? We start to ask the question, how does this fall apart? How does it break? How does it crumble? Because all architectures will crumble. And they crumble at different stages. Okay, so your picture of the architecture, the structure that you have in your head, your beliefs about how this human and business system are going to work, that's a structure that you create at the start of the project, and inevitably that structure will crumble and you'll realize that I was wrong about almost everything. Everything that I thought at the start of this project was wrong. And that's something that the Agile movement should have taught us, that's the way it works. But there's still people out there who try to define everything on day one of a project, or they don't realize that even if we work in an agile way, if you have an idea and you're stuck on that idea will stay in the project forever. We have to be able to get rid of it. And so what I do is I take this naive architecture and I start to stress it. And I started to say, well, what if we're wrong? And we do this in a very, very different way than people usually do with edge cases or with scenario analysis or with risk analysis, because those are very, very different things which happen at a different stage in the project. Now we're actually testing our structure and we're saying, what could I have misunderstood? And so what we do is we make things up and we say, okay, well, we have this thing and there's an assumption here. There's an assumption that a customer has a certain amount of money. What happens if they don't have that amount of expendable income anymore? There's an assumption that the market is open. What happens if there's changes on a regulatory basis? What happens if our competitors start to behave differently? What happens if the partners that we need to work with start to behave differently in the market? How does that affect the structure or my understanding of that system? And what would this naive architecture that I've come up with, what would that look like in terms of in terms of this particular form of stress? And this changes very much how we describe our system. So instead of me saying, well, let's map some user stories or let's ask our business stakeholders, what are your requirements? Instead of just copying someone else's software, we say, well, what can go wrong? What keeps you up at night? And it leads to an entirely different kind of conversation. It requires a whole other level of architectural skill, because I've got to be able to go into a business and talk to them about their business model and say, what is this? How do you make money? How does that fall apart? What are your competitors doing? Who are your competitors? What's your relationship to your government, to your society, to your markets, to your customers? To social norms and trends and political ideas that are moving and shifting all the time. And for a lot of software developers, that's a huge, huge jump in terms of how big is the problem. So we're still doing programming. We're still talking about what is the structure of this program, but we're talking about things like organizational culture and political change and economic variability and volatility, and how does that affect the software that we're going to build. And it moves us very, very far away from this traditional architectural approach of let's map some capability, let's map some process, let's capture things in terms of language and model that language. And so what happens is over time, as you stress the application, and this was the way I worked as default, and I never thought that much about it. I thought I was just negative in that I approach things from this perspective. But what you find is that when you stress an architecture like this, your original naive architecture starts to fall apart. And you have to put it back together every single time in a slightly different way. And after a certain amount of stressing of the architecture, what you start to notice is that as you introduce new stress, the system doesn't need to be changed. It starts to survive things that it hasn't been designed for, which is exactly the goal that we should be aiming for as architects. And so as a programmer, you're taught at university that you have a problem and there is an answer, and that answer is correct or not correct. And it's very binary. It either solves the problem or it doesn't. There is a correct answer. As an architect, there's no correct answer. There's no correct structure that is the absolute right. There are many, many, many possible structures that could solve the problem. And there's no way of knowing which one of them is correct. And this methodology allows us to test and say that this architecture might not be correct, but is it critical? Does it have the property of criticality? And the property of criticality means, can it survive in conditions that it hasn't been developed for? And so what we're doing is we're taking this naive architecture and we're stressing it until it falls apart, and then we're using different methods to put it back together. I just gave a talk yesterday at a conference on AI, where I was talking about the similarities between this kind of thinking and the use of something called a diffusion model in AI, where we add noise to pictures and chart the journey from a picture to noise, and then use that journey to move backwards from noise to produce new pictures. And that's more or less what we're doing here. The mathematics for us isn't as formalized because there's too many variables and too many things moving, but it's a very similar process to a diffusion model within AI. which allows us to produce new architectures out of noise. And so these stressors, these things that happen to a system, aren't necessarily things that are going to happen in real life. It doesn't matter whether they happen or not. So it's very different than edge cases, very different than risk management. People mix those things up because they feel that they're kind of similar. And we're talking about things that are outside of our structural understanding of what's actually happening. And that's what we have to do. That's what we have to test. And one of the things we've lost in traditional architecture is that there's a very big separation between the fractures in an architecture, the way that we break an architecture down, and the kind of things that can expose our structure to problems. And there's a very big difference between that and organizational and business risk. Those are two completely different things. And also it's a completely different thing than technical risk. How can this system break? So there's three things: technical risk, business risk, and architectural change. And because they all look similar to each other, we bake them into one process in most projects. And we lose a lot because then we're not doing architecture anymore. We're just doing risk management or edge case management. But this is more about doing architecture than any of those other things.
Super. Well, super answer. Thanks a lot. We've covered a lot. And this gives me actually a good hook for my next question. At one point you said that's something that developers need to do, but a nice way to put it is not for all levels of expertise, I would say. So my next question would be, so who are we aiming for with this workshop and with your theory as a whole?
Yeah. So the way that this works is that to understand what I'm talking about, you have to have been around for a few years at least. You have to have designed software solutions, and you have to have experienced that the tools that you're using, the way that you map things, are actually incredibly limited compared to the complexity of the environment that you're working in. And I think for most software engineers, if you're working within enterprise environments, it only takes a few years to figure out, or in some cases a few months to figure out that the way that we've been taught to think in terms of rationality and logic and math at university doesn't hold up in the real world. We can't predict or control the way that things are going to move in a business environment. So anyone who's had a couple of years experience in software engineering and is starting to make design decisions and starting to realize that there's more going on than just code and just algorithms and just patterns, anyone who's been exposed at that level will find this interesting. What I find in reality is that once you teach a few people this kind of approach, it spreads right through, even to junior developers who will start because they know what's coming further down the pipeline. And as they're making decisions, as they're putting perhaps smaller code structures together, they'll start to stress the environment, and it becomes a way of behaving as we're designing software systems. But the workshop itself is for, I've had senior enterprise architects, I've had senior developers. There's quite a few senior developers who take the course and get a lot out of it. I've had people from operations, I've had project managers, I've had CTOs who come on this kind of course. Sometimes I get senior managers who are very interested in the ideas. And so it seems to have a very, very broad appeal. But it's for anyone who is interested in finding new ways of answering the question, what should the structure of this software application be? And that's not just architects, but that's any software engineer. And anyone who's feeling the pain of a lack of organization in how you make structured decisions about software. But at the same time, I know that there's a lot of people who are very skeptical about traditional approaches to architecture and enterprise architecture. And for those people, this is a brilliant way out of all that formalia and control and centralized thinking that traditional architecture had. And this gives a much better way to make solid architectural decisions that you can back up. Without having to go into that world, which is largely being discredited in the last 10 years.
Thanks for that. So we have now a clear idea of who we should expect to see in the room. And with this, I would go with the first question from Marco Perone. Thanks for that. So I'll read it out loud together with you. I think we kind of already answered, but let's give it another go. How do you prove things in software architecture like you do in math or some other way?
Yeah, so it's not possible with a software architecture to produce mathematical proof in the same way that you can produce a mathematical proof for a particular algorithm or for a mathematical theorem. Within software architecture, the only thing we can do is to prove that the architecture will survive things that it hasn't been designed to prove. We can prove that it has some degree of criticality. And there's no number that we can put on that, because you can't, and this is one of the huge problems with software engineering research, you can't compare a project that's being executed in Milan by a team of 5 people with a project that's being executed in Berlin with a team of 50 people in a completely different industry. And so actually proving things in software engineering is very, very difficult. And it's easy to fudge things and say, hey, this worked. And so what we get is case studies and the case study is presented as proof. And we say, oh, look, this worked over here and it worked over here. And this worked really well at Spotify. And then the whole world tries to implement it and it doesn't work anywhere and everyone gets confused. So the way we do things in the way that I do things is to use our own initial structure as the control. So you design an architecture, and that's your naive architecture, and then you start to stress it. And at the end of the day, using a bunch of techniques, we use things like we use stress, obviously, and we use things like matrices to compress these architectures and filter them and put them back together. Which was a kind of a denoising process. And we use tools like failure mode analysis to push this into a single coherent architecture. At the end of that, we run a fairly simple mathematical test against the naive architecture, which is our control, and the new architecture, which is what we've done. And we say, which one of these is most likely to survive something that it hasn't seen before? And we can actually, and what I've shown is that in a statistically significant way is that when we go through this process, we will survive things that we haven't designed the system for in a better way. And so that's how we prove that we've actually done that the software architecture actually holds up. How do we? And then you have to, of course, prove as a normal developer that it works functionally, and we do that obviously with testing. In whatever way it feels most appropriate to us. But that's how we prove that the software architecture actually does something useful. And that's how we would compare two software architectures, because that's the thing that's important. For any one particular problem, there are thousands of potential architectures that could work. Which one do we want to have? We want to have the one that's going to survive the surprises that we all know are there.
Super, thanks, Barry. So, Marco, if this answered the question or not, let us know, and we can dig a bit more into that. Thanks, Barry, again. So we have a new one by Ashley. Thanks, Ashley. So what are the patterns or archetypes of stressors? Ways that you can formalize the concept and not take an ad hoc approach to identifying relevant stressors. Okay.
Yeah. So I think the answer to this question is that you have to take an ad hoc approach to identifying relevant stressors, and so this is one of the key things. The things that are going to stress your architecture will almost always they have to be concretely related to the context that we're working in. And those contexts shift and change from project to project to project. And so one of the first questions I get when I present these ideas is that someone will say, but is there a list of stressors that we can just take and use in every single project, and then we won't have to think about any of these things? And that is that tendency has always been there in architecture. How do we boil this down? How do we make this abstract? How do we make this repeatable so that we can do it over and over and over again? And I try to stop architects from thinking along those lines. It's like every time you go into a context, you can't assume that things are going to be the way they were before. And one of the things that I was talking about on LinkedIn yesterday, and I got a little bit of heat for it, was that we need to stop doing architecture by checklist. So you can't do architecture in unique context with a checklist that's being produced in the past, because things are shifting and changing and moving all the time. And so one of the things I do though, which I think will answer Ashley's question a little bit better, is that there are certain classes of stressor that, if you miss them, will make your architecture much weaker. So one type of stress is technical stress. So I have a bunch of components connected to each other. What happens if one of those components blows up? And what happens if there's a change in the structure of one of those components? What happens if there's a third-party component and that third party goes away? Another kind of stress, and one that people usually struggle with, is business model stress. So I have a business model. I have money coming in, I have money going out. What happens if the money going out suddenly increases? How does that impact my architecture? In that business model, I have partners. What happens if those partners raise their price, stop delivering in the way that they've delivered? What happens if they start to compete with me? What happens if the value in the product that I'm delivering suddenly is seen as not being particularly valuable, or that it's actually a cost? And that allows us to generate stress around the business model. But in order to properly talk about stress in our architecture, I have to be able to connect those business level stressors and those political stressors and economic stressors to the technical stressors inside my architecture. And every single time we do this, that's a journey, because you're constantly learning, what is this environment? How does it work? What's the relationship between this component breakdown and this particular economic situation in this particular market at this particular time with this particular product? And so part of the skill that an architect has to have is to be able to answer the question, for example. So one of the ways that I'll introduce this topic is to say that you're building an architecture, you have an architecture. What happens in your architecture when a competitor drops their price? And that's kind of testing, where are you as an architect? Are you still down in the weeds dealing with the technical stuff, or can you relate this change in a market which seems very far away, very esoteric to a lot of technical people? When a competitor drops their price, where does it hit your architecture? And so part of the point of this course is to get people to have the level of architectural maturity to be able to answer that question, because it does impact the architecture. Absolutely. Your architecture will change based on your business's response, and that's a form of stress. And so the way of generating stress has to be left open, and as an architect, you have to realize that this is going to be a new thing every single time. And it's not something that can be written as an algorithm or follow a certain set of practices. And if we tried to do that, it would just end up being another TOGAF. Do A, then do B, then do C, and then it would be some sort of magic formula for producing architecture. And so one of the skills that I teach, rather than a process or a pattern, is you're an architect, you're going into an entirely new environment with a new market, new customers, new technologies, because these things are changing all the time. When you put all these things together, what's going to stress them? And being able to answer that question is what architecture is all about, I think. I hope that's an answer to your question, Ashley.
Let us know, Ashley. Well, we never said it was easy, right?
Yeah, but it's a very common question, and the truth is not as black and white as I've painted it. You will, as you start using these ideas, you'll have a set of stressors in your back pocket that you bring with you all the time. The important thing is to realize that those aren't the right stressors for every single project, and you'll have to modify them and make them grow. But you'll learn that the richest source of stress is in the business model and in the assumptions that we make about our relationships with other actors in the market, and that technical stress is related to that, and creating the relationships and understanding how those things move and affect each other are incredibly important.
Cool. Yeah, Ashley says a great answer. Thanks. Thanks for that. So I would go back to our list. We have another one by Sebastian that I will read in a second, but we already mentioned basically not only who is this for, but who is a software architect. I'd like to dig a bit more into this, because of course we might have a fairly agreeable understanding of who is a software developer, but how about software architects? So what do they do? I know it sounds weird at 34 minutes into this live, but I think it's still good.
Yeah. So this is an enormous question, and I've been a member of architecture communities on different levels, I guess, for very, very many years, and I've led large architect communities at Microsoft, and it's absolutely fascinating how this question never goes away. And the reason the question never goes away is because we never actually answer it. And so what is architect? An easier question to answer for me is, what is software architecture? And software architecture is the structure. It is the structure of a software application. And what is its structure in terms of what hardware is it running on? What are the components? What are their boundaries? How do they talk to each other? Where are they? And more importantly, of course, how do they feel and how do they fall apart? And so Grady Butch would say that an architecture is all the significant decisions that we make in a project. And I more or less agree with that. And the truth is that software architecture that pops up at some point in our work. There is a structure here, and the question is, where did that come from? And the idea that it's one person who has the title architect who has made all of those decisions, because there are tens of thousands of decisions in any simple software structure, is a ridiculous idea. Decisions are made by developers, as they should be, as they build components, as they relate those components to other components, as they make calls and interactions. And some of those decisions are made by people who have the title architect. But architecture is really just those people are really just advanced programmers. And so they started to answer questions above and beyond: how many functions should that have? How many arguments should it have? How should I put a boundary around them? And they start to ask questions about how does that boundary relate to the business environment that we're actually working in, to the commercial environment, to the social environment. And so there's an article I read last week from the 1980s about how architecture really is just advanced programming. But there's also project managers, and they are making decisions, and they're making architectural decisions, and they're not always entirely aware of that that's what they're doing. And there were people within the business structures, within the managers and domain experts who are making decisions that affect the architecture. And all of those things together produce the software structure. And so that's what architecture is, and all of those people contribute. And the more of those people who understand that these things are deeply uncertain and have to be stressed in order to give us some viability within a changing environment, then the better things will be. The actual role of software architect then becomes the role of making sure that there's coherence across these decisions, that people are free to make the decisions they need to make, and that those decisions are coalescing towards something coherent in terms of the structure. And I see it very much as a rule that sometimes we'll take the bigger, heavier decisions that have to be made. Sometimes we'll make people aware of those decisions. Sometimes we're just a funnel for someone deeper in the project, a developer who discovers something that isn't good or isn't thought through, and pushing that back up into the business layer. But architecture is something that's done in a very distributed fashion. It's not something that's done by one particular person, but you'll find that the more senior someone is, the more time they're spending on architectural decision making. But everyone is somewhere on the ladder. And so one of the things I'll teach is that if you're a senior architect and you're capable of working at this level and you're capable of looking at business stress, it's your job to make sure that the developers in the team also know what you're doing, and they also learn how to do it from you. Because that's been a huge problem we've had in software architecture, is how do we train the next generation? And that becomes very difficult whenever architects are seen these old fuddy-duddies who run around with PowerPoint and lines and boxes, completely disconnected from the real world of code and crashes and incidents.
Super, very interesting. And I see a lot of no pun intended again, on decision making, because of course we know that we also 1 or 2 years ago we published a book called Decision Making for Software Development Teams by one of our trainers, Francesco Strazzullo. And one of the points is actually we software teams and developers make the decisions without even knowing that. So that's a big wow. That's like thought about it, but I'm making decisions every day, which is not only the framework you are using, but also on a higher level. Well, probably the more senior you get, the more you are aware of that. Generally speaking, there's a lot going on when it comes to decision making, which is just not even considered probably as part of the process.
Yeah, and so decision making as a collective, as a group of people, is something that is so complex and so varied and implicitly volatile that it's not something that we can capture in lines and boxes and processes and frameworks and say this is the way we make decisions about this project. It just doesn't happen like that. And traditional old school architectural approaches have all assumed that it does actually happen like that, which is why they've more or less been excluded from modern discussions about architecture, because it just cannot work like that. And it's one of the things I do as a consultant is I tend to work a lot with crashed projects, and so we'll go into projects that have burned out or they're not working, they haven't delivered, and I'll come in. Usually whenever someone assumes there's been an architectural failure, and I'll come in and they'll say, what did we do wrong, or what's happening here? And so the first thing I'll do is I'll say, show me an architecture, show me a drawing, and someone will sketch something. And I'll say, okay, here you've chosen to do this particular task using 2 components. Why 2? Why not 1? Why not 15? How did that decision get made? And the whole room will then, at that point, look terrified and say, we don't know. We don't know why it looks like that. We have no clue. And there's actual research, which I talk about in the course, that's been done on a wider scale that shows that in the broader industry, developers and architects don't know why their solutions look the way they look, which means that decision making is some sort of weird ad hoc woo-woo thing that no one really understands. And so one of the results of taking this workshop will be that you'll be able to point at that and say it's 2 components because of this, because of the way that stress interacts with the system. We see the fracture lines here and we've put them here. Because this has given us a system that empirically shows a better ability to respond to unknown sources of stress. And that gives us a justification for our component boundaries.
Wow. Yeah, it's a perfect example, and there's many in the book, and I'm sure we'll see a lot in April, and looks really interesting. So we go to Sebastian. Sorry, you want to add something?
No, go ahead.
We go to Sebastian's question, and then I think we are near to the end. So, folks, if you want to ask something to Barry, that's your time. So, Sebastian, thanks a lot. How does residuality translate in practice in development? Are experiments like code probes that your regression test in a pre-mortem fashion as a mechanism of stress, or is this purely done in modeling?
So, from a business perspective, when I pick up on a business stressor, for example, it's a thought experiment. It's done in modeling, and it has to be, because I can't go out into the actual market and force a competitor to drop their price. That's a very difficult experiment to set up and run. So it becomes a thought experiment. As we get closer and closer to technical stress, then it begins to become something that we can actually run as probes. And so I say, well, if a competitor drops their price, we're going to have to drop our price, which leads to an increase in volume, which means we're going to have to scale up on these servers. Can we actually do that? Does the architecture allow us to scale up? And then as an architecture, you can say, yes, it does. And then you have to ask the technical question, does that scaling up actually work the way we think it's going to work? And that has to be done with an actual probe. Can we test this? Can we make this actually work? And all of those steps are part of the work of software architecture. That's what we're actually doing. It's not only how should this thing look, how should the components be broken down, do they allow us the flexibility to move to a different kind of architecture in a different set of business circumstances, and will it actually work? So in a lot of this work is done on whiteboards before we ever get to anywhere close to code, so that we have a good understanding of the kind of structures that are going to exist before we get there. And in development, it requires a lot more thought than a lot of teams currently put into the structure. And so it can be accused of doing too much upfront. But that's absolutely nothing to be ashamed of. And I think that's something we're going to see change over the next couple of years. That we will be doing more thought work up front. In praxis, there's a bunch of tools we use. So there's stressor analysis, which is very human focused. It's very much about capturing uncertainty. It's very much about having discussions. And what we do is we actually replace the process of requirements engineering and a lot of modeling and risk management. We replace those in the architectural phase. And then there's a lot of use of matrices to decide what are the actual components in this structure. How do we know where the boundaries are? Where are the fault lines in this architecture? And then we move into things like FMEA analysis, which makes a lot more sense to developers, which is very much about hammering the technical architecture until we see where the fault lines there are as well, and making sure that there's a relationship between these things. And so a lot of the focus is on validating and verifying, making explicit the decisions that you've made, and validating and verifying that those decisions are correct. But before that, we're giving developers and architects a philosophical and scientific basis for making those decisions, so that we're not learning by trial and error, which is a very, very expensive way to do architecture. So one way you can solve these problems is to just say, oh, well, we'll use two components because it feels good, put them into production and watch how they fall apart, and then rebuild it, and then rebuild it again and rebuild it again. And that's what we're trying to avoid here.
Thanks, Barry. So this leads to one last question I have for you. Folks, if you want to ask one, that's like the last call, which is all of what you mentioned. I made the joke before, like nobody said it was going to be easy. And of course, we kind of can guess that. But how does that work in practice? So we are basically talking about a complete switch in mentality and way of working. I guess what you said, it's we're going to be seeing a lot more of this in the future, which hopefully that's what's going to happen as people, get used to it and understand the value of it. But how is it working? So this is like twofold. So how does it work in a team once you implement this new way? And if you've seen any resistance kind of thing to this, because as all new things, there can be some.
Yeah, so I find that that this works in a team incredibly well. Once people start thinking this way and they start approaching things this way, if you have 4 architects in a room, okay, they've all become architects or senior software developers, usually through completely different career paths, different projects, different experiences, different industries, and they've got very different ways of doing things. And one of the things we lack to talk about what we do. And so it becomes a lot of gut to find people clashing over approaches where they say, no, I want to do it this way, or I want to do it this way. I read this blog, or I know this person and they said this, and I read this book. And what we tend to find is it's very, very difficult to communicate with each other about what's the best approach. And there's no scientific way to figure that out. Once you have these kind of approaches, it becomes much, much easier for a team to express themselves in a coherent way. And so instead of me saying, I think we should use this language, this pattern, this particular component, and then fighting with everyone about why it's better than theirs, then the rest of the team will say to me, okay, well, how did you get there? What kind of stress exists in the environment that we need these particular things? Or if my idea is particularly naive, then the whole team will stress it until it breaks. And then people start to move towards a center that it becomes easier to solve problems. So in terms of making a team work together in software engineering, it works much, much better. In terms of resistance, there is always resistance to new ideas. And that's part of the fun. And when I first started talking about these ideas 10 years ago, some people would get very upset because there are certain things you weren't allowed to say 10 years ago, such as enterprise architecture is a field project, or agile doesn't solve all our problems. It used to be incredibly controversial to just make that statement. And I've had people in London who were ready to throw chairs at me from the audience because I was saying that some of the practices, some of the things that we do, you can't do architecture by checklist. Drawing processes in a room in the basement for each other isn't architecture. And architectures can't emerge, or when they do, they're rubbish. And people tended to get offended because a lot of what I'm doing is pointing out the flaws in some of these older methods, these older ideas. And for a lot of people, there's a lot of comfort in those older ideas and those older, especially if they've seen them work in a kind of anecdotal fashion in projects that they've worked in. And there are some people who push back and say, but you can't do this because you can't meet every stressor, you can't solve every single problem because it costs too much. And that's when people say that, they've misunderstood the approach, because we're not going to solve every single problem. In fact, the stressors that we use to generate an architecture, we throw them away at the end of the process. They're not even relevant, and they can be entirely fantastical. They don't have to be real. They just have to let us understand where the fault lines in our architecture is. All we have to do is produce an architecture that moves easier. It doesn't necessarily have to solve every single problem. Some people will say, oh, this is just edge cases. We've already done this. And, Matthias Varais from Domain Driven Design Europe wrote an excellent blog article where he said, the just like fallacy, where people try to understand a new idea in terms of old ideas. And they say, well, this is just risk management. But it's not risk management, because we're not actually managing the risks. We're looking for fault lines in our architecture. We'll manage risk at a later point in the project. It's not just edge cases, because the very word edge case means that we're working on the edges of the structures that we think exist. And therefore we're putting faith into the structure. Well, this is about destroying the structure from within. It's much more radical and fundamental in edge case analysis. So there has been a lot of resistance, but one of the things I've noticed in the last year is it used to take me 4 days to teach an architect how to use these ideas, and those are 4 tough days, because there's a lot of new ideas, a lot of thinking, and then it started to work after 3. And recently I was in Germany and I did this in 1 day. I got people up and working and proving that they'd improved their architectures and coming with numbers at the end of the day. And so the resistance is getting less and less, partially because people are getting used to the ideas and the things I say aren't as controversial as they were 10 years ago. Partially because they're meeting people who are saying, I do this and it works. And partially because I'm getting better at explaining it, I hope. And so the resistance breaks down. But an idea should have resistance. I've seen people in our industry do this thing where I can get up in a stage and I can talk about something and I can get 100% of the people in the room to applaud and 100% of the people in the room to agree with me. And that's a sure sign that I've said nothing concrete and nothing sensible and nothing useful. There has to be some tension, and you should feel some tension when you're introduced to a new idea. And in the long term, within the next few months, I'm going to publish my PhD thesis, which shows that these ideas work in a statistically significant way. So if you want to resist the approach, that's fine. But you'll have to, if you want to argue about it with me, you'll have to produce some peer-reviewed evidence that it doesn't actually work. But resistance is natural and normal. And if people are honest about why they're resisting something, I'm resisting this because it makes me afraid or it makes me scared, then that's fine. What I usually say, though, a lot of people tend to listen to me talk about this for an hour and then come with some knee-jerk reaction, which is normally one of 5 or 6 different arguments. This is a big thing. This is as big in terms of the space it needs to fit in your head. This is as big as object orientation, and really we're looking at turning this into undergraduate courses for universities right now. And this is going to be 2 university modules. There's a lot going on here. There's a lot that you have to understand, and there'll be resistance simply because of that. There's a lot of work that has to be done to really get these ideas to click. I gave a talk in Stockholm last year, and a guy came up to me at the end of the talk, and I thought, I recognize this person. And he said to me, this is the 4th time I've seen your talk, and now I get it. And it seems to be a general rule of thumb that you have to see the talk 4 times because there's so much going on. Because this goes right down to philosophy and how do I look at the world and how do I think about the world and the organizations around me, that it takes a lot to get these ideas.
Okay, so we'll make sure we link to the talk, so folks who come to Milan have already something in mind.
Yeah, they should watch it 3 times before they come.
Excellent. Thanks, Barry. It's been a lovely chat, so much insight, and hope everyone from home enjoyed it. Yeah, I just published the link to the workshop, so we are going to be, I'll quickly share it on the screen. Share screen. We are going to be in Milan next year for 10th, 11th, 12th of April. Here is the description. I'm gonna add the video here too, and probably we'll make a blog post of this conversation because, as Barry said, we need to digest it a bit. So written form can help as well. I would say that is it. Thanks a lot for being with us, and talk soon.
Thank you.
Thank you. Bye-bye.
Bye-bye. Bye.